In the previous class, we were discussing, uh, we started some basic statistical task. So I have told you that initially you need to know, before knowing the distribution, you should know that uh, the discrete variable quantity. So here, so we have already known that. Now we will start the distribution. So the distribution of a statistical data set or a population is a listing or function showing all the possible values or intervals of the data and how often they occur. Okay. And probability distribution describes what we think the probability of each outcome is. For example, flipping a fair coin has two outcomes. It lands heads or tails. And before the flip, we believe that there is a 1 in 2 chance or 0.5 probability of heads. And also the same thing is for the tails. And that's a probability distribution over the two outcomes of the flip, which is actually known as Bernoulli distribution. And some distributions are discrete over outcomes that must be integers like 1 or 6. Suppose, for example, the outcome of a dice. And in this case, along y-axis, we represent the frequency of the outcomes. You can see that this is the discrete distribution and the continuous distribution. So some distributions are continuous for outcomes that can take on any real numeric value, like suppose the height of a group or students. So these appear as dense curves, where its areas under selection of the curve that gives you the probabilities, and the sum of the heights of lines and areas under the curve are always 1, and hence along y-axis we represent probability density. Okay, so for in a continuous distribution, along y-axis we are representing the probability density. Okay, now probability density function, it is a function that defines a probability distribution, like the likelihood of an outcome for a continuous random variable as opposed to a discrete. The distribution curve never touches the x-axis because it is the curve of the set of observations, and each observation has some likelihood, and the likelihood can never be zero rationally. Okay. So earlier you have known about in 12th standard, you have studied the concept of function. So probability density function, it is also nothing but a function. So what is the concept of function? Suppose y is a function of x. So for any given value of x, you will be getting the value of y. Okay. And the function will be given like that. Okay. So that is the concept of function. So here also it is the same in case of probability density function. Suppose if this is you take the normal distribution, there for the normal distribution, and if you put the values of x, you can calculate the values of y. So that is the probability. So that is known as the probability density function, and here the y-axis actually it will represent the y-axis. It will represent the likelihood of a particular outcome. Okay, it's not term probability, because the likelihood is basically, it is a conditional probability. So I will later on I will discuss the difference between the probability and the likelihood. Okay, so now let's take a look at the probability mass function. So it is a function that gives the probability that a discrete random variable is exactly equal to some value. Probability mass function differs from a probability density function in that the continuous discrete random variable. A PDF must be integrated over an interval to yield a probability. And the value of the random variable having the largest probability mass is called mode. And thinking of probability as mass helps to avoid mistakes, since the physical mass is conserved as is the total probability of for all the hypothetical outcomes of X. So what is happening as of probability function? This is basically applicable for the discrete variables like this. So earlier we have shown you that the difference between bar chart and histograms. Okay, for where the bar chart is used for categorical data. Okay, and in this case the histogram, this is basically for the continuous data. We have, suppose the age, the ranges that we have considered for the histogram. So here also it's based on the nature of the variable. This, the discrete distribution or continuous distribution, it is also the nature of the variable, the outcome, the type of the outcome. So here the summary is given. Okay, the summary, you can see that the random variable and the continuous random variable, the summary is given. uh, you should remember this thing is very important, that how the probability is actually calculated. In case of the discrete random variable, the probability is calculated adding up discrete probabilities of interest. Okay, so just like this, what does it mean? P is x less than or equal to 8 is equal to 0.3 plus 0.5. It means that what is the probability of the value of x will be 8 or less than 8. So all the values that are before 8, the outcomes, that values you should add the probability. So if you take into account all those values, that means those are actually termed as the likelihood, you can say. So that will be the final probability value. And in case of continuous random variable, it is counted as the area under the curve for the range of interest. Okay. Suppose I would just like to give an example, the difference to make you understand about the difference between here the probability and the likelihood. Suppose many of you have gone through the course of project management, right? So in the project management, you have seen that whenever you have solved the problems related to CPM and PART, critical path method and program evaluation review technique, you will see that these kind of questions are asked, that what is the probability of that this project will be completing by 45 days. Okay, so now if you want to calculate the probability of the project will be completing by 45 days, so you will take, suppose if this line represents the value of 45. Okay, so you will be counting all these the previous values as well. Why? Because it may be completed by 44 days or 43 days. So those probabilities also you need to take into account. So that's why this is also known as cumulative probability. Okay, so uh, that is actually here in this way you calculate. But if you are asked that what is the probability of that project, that particular project will be completed at 47th day or at 45th day, that means it is if it says on the exact date, then you will just simply you will be calculating the height of the uh, y-axis, and you know that the value of x. So if this function is given, so you can easily calculate the value of the y. So this is actually the difference between the likelihood and the probability. Likelihood is also probability, but it is a conditional probability because in that case the outcome is fixed and you would like to know the probability of that particular outcome. Okay. So now we will discuss about the standard error. Suppose there are five, you are going to uh, do some sampling. Okay, and you are dealing with the weight of mice. So randomly, suppose you are picking 5 mice and you are doing the experimentation for 5 times. Okay, so you can see that this is the first time, this is the second time, third, fourth, fifth, and these dots that you can see, they are actually representing the values. You can consider this line as the x-axis. Only it is a one-dimensional graph you can think of. Okay, so now you can see that you will for 5 different experiments you will get 5 means or average, one for each set of measurement. Okay, so we would also have 5 separate standard deviations around the means, one for each set of measurement. Why? Because you have taken 5 different values. That's why 5 different means you will get, 5 different standard deviations you will get, and they quantify how much the measurements are spread around their means. Okay. Now the standard deviations of the mean is actually called the standard error. Okay. So if you are asked that what is standard error is nothing but it is the standard deviation of the mean that you have calculated, the standard deviation of the mean, that is actually known as standard error. So it is uh, the formula you can see that it is calculated in this way, standard error. Okay, so uh, suppose these values are given, so you can calculate the mean value. Okay, and n is equal to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, the sample size is 10, and the standard deviation of this, that means sample standard deviation is 0.826. So the standard error you can calculate as the standard deviation of the sample 0.826. It is divided by root n, small n, which is the sample size. Uh, you can calculate the 0.261, that is your standard error. Okay, so this is known as the standard error of the mean. And if you want to know that why the formula is like that, why this formula is given, okay, so here you can check out these two links of YouTube video where it is provided that how this formula we can determine. Okay. The difference between the probability and the likelihood, this I have already discussed. Okay, so you can check out this once again. Okay, now there are some parameters of distribution you would like to know. So what are those parameters of distribution? Probability distribution is characterized by some parameters like location parameter, scale parameter, uh, shape parameter. Okay, so now let's go through it. What is location parameter? It simply moves the distribution left or right on the horizontal axis. For example, location parameter for normal distribution is its mean u. Okay. What is scale parameter? It simply stretch or squeeze the distribution. The greater the scale parameter value, greater the stretching will be. So the scale parameter for the normal distribution is its variance uh, sigma. The standard value of scale and location parameter of any distribution is 1 and 0. And shape parameter, it affects the general shape of the uh, distribution. For example, beta distribution takes different shapes depending on the value of shape parameters of alpha and beta. It's not necessarily that all distribution will have shape parameter. For example, normal distribution doesn't have the shape parameter. So these are the parameters by you know so uh, by means of which we can know that what how the distribution will look like. That can be what will be the location or the type of the distribution, like it is more squeezed or more stretched, so that we can determine from the these kinds of the parameters. So we will look into this thing in more detail when we will go through the some specific distributions. Now, modeling these parameters is actually nothing but fitting the particular distribution for the collected sample data. This is called as distribution fitting. There are different methods for distribution fitting. Uh, some of them are method of moment, maximum likelihood method, the regression method, etc. So these methods, so how to model these parameters or how to fit from the nature of the problem, we can understand that what kind of distribution we should fit. Okay, and we may verify it. But after that, uh, uh, even if we know that what kind of distribution will fit, then the parameter of that distribution that needs to be estimated, because in order to know the location or the scale or the shape of the distribution, which in widely in many cases in we use the maximum likelihood estimation method for that, so that we will discuss later. So now the central moment. Central moment is a moment of a probability distribution of a random variable about the random variable's mean. That is, it is the expected value of a specified integer power of the deviation of the random variable from the mean. The various moments from one set of values by which the properties of a probability distribution can be uh, usefully characterized. Let's take a look at the Next slide. Okay, you can see here uh, uh, this is given for the normal distribution. We know that the mean, many times we have talked about the mean. So what is mean? Mean is the measure of central tendency. Formula is given here. This is termed as moment number one. Then the variance. Variance is the measure of the dispersion. Here the formula is given. It is moment number two. So similarly, uh, the skewness, that is the measure of the symmetry, positive or negative, that is moment number three. And obviously kurtosis, which is the measure of shape, uh, uh, whether it is tall or the flat. So that that is called the moment number four. Okay, so defining first, let's define the skewness. The skewness is the measure of the asymmetry of the distribution of a real valued random real valued random variable is the standardized third central moment of a distribution. You can see the formula. And sum of deviation from mean value divided by the cubed standard deviation. That is the formula. So this is left skewed symmetric, and this is the example of the right skewed. So you can see this, and underneath it you can also see that the box plots are given. Okay, this is actually known as box plot, and how to draw this box plot, that we will discuss later on. But as of now, we will just know that what is the left skewed symmetric and right skewed, so that we can measure, we can have an idea. Okay, kurtosis is a measure of the pickedness of the probability distribution of a real valued random variable. So it's the standardized fourth central moment of a distribution. Okay, so here also you can see that mesocartic, leptocartic, and platycartic. So these are three nature. So basically it is how much the height of the distribution is, that is measured by the or the pickedness, that is actually being measured by the kurtosis. So this is given for a normal distribution, the excess kurtosis value, it is uh, 0 in this case. If this is it is mesocartic in nature. So leptocartic, this is, you can see that is, this is known as platycartic. Okay, so different types of the kurtosis it is given here. For a normal distribution, kurtosis is equal to 3 and is said to be mesocartic. Okay, when it is greater than 3, the curve is more sharply picked. Okay, and it is said to be leptocartic, like that. And when it is less than 3, the curve has a flatter top and relatively, wider tails that the normal curve, and is said to be platycartic. So so uh, now we will describe more details on the types of distribution. So as you can see here that there is a lot of distributions, like, but we will classify it as as variables distributions and the distribution which are based on the continuous variables. Okay, so Disc discrete distributions we will discuss, we will focus on the binomial distribution or Poisson distribution, and in case of the continuous variables we will focus on the exponential distribution, Weibull distribution, normal distribution or standard normal or Z distribution, students T distribution, chi-square distribution. If so, I'm not going to tell you that how actually the formula are derived, because it is a pretty complicated process, that how the formula derived for formula means the probability, the density function, how this is derived actually for each and every distribution. Not very complicated, but it will take much more time. But if you wish, you can go through this link here. You will find that the binomial distribution, how the mathematically they are deriving, the mean can be derived and also the variance can be derived. Mainly our focus is on the derivation or part of the mean and the variance. Okay, so binomial distribution describes discrete data. It means situations where there be two results in a random experiment. Suppose, for example, pass or failure, compliance or non-compliance, yes or no. Okay, so you will see that in mm, total quality management there is a control chart for attributes, you can see. Okay, and there in case of control chart for attributes, you will see that there P chart, C chart, U charts, these are used, and P chart and NP chart, they are used for the defects, whereas the C chart and U chart are used for the defectives. Okay. Uh, uh, so so here actually where you will of the normal the two types of outcomes you will have, you can use the binomial distribution. So let's take a look at an example. So measures of the central tendency and dispersion. So what are the formula that we will see? So P is equal to probability of success, Q is actually the probability of failure. So if P is the probability of success, so automatically Q, okay, and the mean is given by NP, and the standard deviation is given by root under NPQ. Okay, and n small n is equal to total number of observations. Let x be a binomial random variable. Okay, so what will be the probability of x? The probability of x is given by n dash divided by x dash into n minus x dash into p to the power x to q to the n minus x. Okay, so conditions for applying binomial distribution. This is very important. Actually, basically, you need to know this thing. Otherwise, you will not be able to understand where the binomial distribution we can apply. So each trial has only two outcomes. There you can use binomial distribution. The probability of the outcome of any trial remains fixed over time. Okay, and the trials are statistically independent. It means outcome of one trial does not influence the outcome of the other. So in these cases, binomial distribution can be used. Okay, again, the formula is given, and also you can see that how the binomial distribution looks like. So suppose some students are selected randomly Now they are calculating, suppose the questions are given, okay, and each question is having four options. Now they are asking that what is the probability that to get no answer correct. Okay, so what is x? X, so just think about, see the probability formula. Okay, this is the probability formula. What is x? The number of success desired. Okay, but here the x they are actually taking as the you know uh, they are taking as since here the failure is actually taking into account, say that considering here x as not the success, rather they have considered the x as zero or the failure actually. So this is the probability of zero answers uh, correctly. So n is equal to 10 because the number of trials. So since there are 10 questions, so that is they have taken 10, and p is equal to probability getting a success in one trial. So the probability easily understand p there, since there are four options, so the possibility is 1 by 4. Okay, that the answer will be correct. There the probability is 0.25, so 0.25 is given. Okay, so q, the probability of getting a success in one trial, so that is uh, uh, the probability, sorry, q is equal to 1 minus p, the probability of getting a failure in one trial, so that will be 1 minus 0.25, which is 0.75, and x is equal to number of questions answered correctly. Okay, so here suppose the success probability x is equal to 0, uh, sorry, x is equal to 0, the answers no answers will be correct in this case. So you put here 0, and finally you will be getting these values, the probability. So just like simple thing, suppose the probability of getting suppose the number of success desired, suppose if x is equal to, suppose for example if x is equal to 2, that the probability to get two answers correct, how can you find it? So you would simply take it x is equal to 2. So here p will be 2. Okay, so you put here instead of 0, you place here 2, and you will be getting the values. So here you have got the values that the probability of no answer is correct is 5.63. Okay, percentage. Suppose the probability of two answers will be correct. So in that case, you can put these values of 2 and you can get the answers. Okay, so this is actually the binomial distribution. So now let's talk about the Poisson distribution. So the Poisson distribution, it is also a discrete distribution, like just like the binomial distribution, but the Poisson distribution is a discrete probability distribution of a random variable x that satisfies these conditions. Number one, the experiment consists of counting the number of times an event x occurs in a given interval. The interval can be an interval of time, area, or volume. Number two, the probability of the event occurring is the same for each interval. Number three, the number of occurrences in one interval is independent of the number of occurrences in other interval. And the probability of exactly x occurrences in an interval is probability of x is given by mu to the power x into e to the power minus mu divided by x dash. Okay, so mu is the mean number of the occurrences. Okay, so the Poisson distribution, you can see that under certain conditions, the binomial uh, distribution assumes a very confident form. So the some conditions are given, and there is the binomial distribution, and the difference between binomial distribution and Poisson distribution, that is also given, that here in binomial distributions only two possible outcomes are there, and in case of Poisson distributions can be unlimited number of possible outcomes. The why? Because in a particular time interval, the occurrence can be many times, infinite times, in fact. Okay. So now the second thing is the probability of repeated number of trials are studied. Experiment of tossing a coin. The count of independent events occur randomly with a given period of time. The mean is equal to NP greater than variance is equal to NPQ. Here the mean variance is all given by lambda. Constant probability of success and infinitesimal chance of success. So let's take a look at this thing, that it describes discrete data. It means situations where the random variable can take integer values. The examples like number of patients arriving at a physician's office, number of cars arriving at a toll booth. Okay, and the mean is equal to number of occurrences per interval of time is equal to lambda, and standard deviation is equal to root under mean is equal to root under lambda. Okay, so if you consider that the Poisson distribution is an approximation to the binomial, if n is large and p is small, you can get it. Okay, so anyway, the proof is given, and we are not going to the proof. You simply know the mean and the standard deviation of, in case of Poisson distribution, that will suffice. We are avoiding the proof, and the let x be a Poisson random variable. So how its probability will be defined? Its probability will be defined using the following formula. It is equal to lambda to the power x into e to the power minus lambda divided by x dash. Suppose 100 pages of the books are randomly selected. Probability that there are no errors. What will be the probability of no errors? So you can see that the x, no error means x will be 0. Okay, so you put here 0, x will be 0. Now you have been given that the mean is equal to 1.5. Okay, the mean is given as 1.5. 1.5 for a particular uh, volume interval, you can say, yeah, for some particular number of pages. So you put here the mean, lambda is equal to 1.5. You will be getting the value of 22.31%, which is the probability that there will be no typos or error. Okay, so this is the probability. Okay, so similarly, you can take a look at another example. Okay, suppose for a 400-page book, calculate the following probabilities. There are no errors and there are 5 or fewer errors. Okay, and you have been given that a mean of 1.5 errors per 100 page. So if this is the case, if out of every 100 pages, if you get 1.5 errors, then you can easily calculate that for 400 pages, you will get 6 errors. Okay, so 6 will be your mean value or the lambda value. Okay, now they have, in some cases, in some books you will find that they have used the term lambda, and in some cases you will find that they are using the term called uh, the mu. They can also use. Okay, so here they have used mu. So in place of lambda or mu, you just put here the 6, this value. And in case of there are no typos or errors, put x is equal to 0 and you will be calculating the value of the probability. Okay. But whenever you will be calculating there are 5 or fewer errors. Okay, so then how you will calculate? You will calculate like this. You will have to calculate like when the p value is 0, p value is 1, p value is 2, p value is 3, p value is 4, and p value is 5. Okay, because only 5 the value will become this. We have already discussed about the probability mass function. Okay, so when in that case you are going to calculate the probability, and it is specifically mentioned that the fewer errors also you should take into account, then uh, it is integer values. You can see, you can understand that this is a discrete variable, like the error can be 0 or the error can be 1 or 2 or 3. It cannot be 2.5 errors or 2.3 errors. It cannot be. So clearly you can understand that this is a discrete variable. Okay, so all these probabilities you need to accumulate or calculate. So this will come out to be 0.4457. Okay, so this is kind of very interesting thing. So now we will take a look at the exponential distribution. So to model the behavior of units that have a constant failure rate, we can use the exponential distribution. It is very often it is used in dealing with the reliability of the electronic products or the mechanical items or products. It is very frequently used. So the example would be like the time to failure of electronic components, the time between consumers' arrivals at a terminal, the time for radioactive nucleus decay, the distance a photon travels in a medium before colliding with dust particles. So in all these cases, the exponential distributions are used. Okay. So one thing I missed, that is you can see that uh, the type of how the Poisson distribution in case of it looks like. It looks like that. Along x-axis you are representing the number of rare events per sample. Okay, and along y-axis you are representing the reliance expected, the frequency you are actually representing. Okay, but you can easily see that how it is depending upon how the shape of uh, uh, the shape or the position of how the position is actually getting changed. Okay, depending how the shape it is changing depending upon the type of the parameter mu. You can see for mu 0.1 how it looks like, for mu is equal to 1, 2, 3, mu is equal to 10, how the shape is getting changed. You can see. Okay, so the same thing, it also uh, 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 depending upon this particular parameter lambda, you can see that how it is the location is actually it is changing for in case of exponential distribution. Okay, now the given x and lambda, the effects it is given by lambda into e to the power minus x. Okay, and the mean is given by measures of central tendency and dispersion. Mean is given by 1 by lambda is equal to, it is the standard deviation. So now one example we can see that the example is like what is the probability that time between two calls is less than 5 minutes. Okay, so how you will calculate that? So uh, uh, where you have already been given that you are receiving 20 calls per hour. Okay, so 20 calls per hour means lambda is equal to 20. Okay, 20 calls per hour means lambda is equal to 20 because mm, uh, yes, because you are you are actually the threshold parameter you are representing by the lambda. Okay, now x is equal to 5 minutes, which is 0.083 hours. Okay, this is actually the x. Lambda is known as actually the failure rate. It is the threshold parameter, and the mean value is also known as MTTF, or mean time to failure. And the probability, you can how you can calculate e to the power lambda into e to the power minus lambda x. So probability x is 0.083. You can calculate it as 0.1901. You will be putting the values of the lambda, and you will be putting the values of x, and what is the probability that the time between two calls is less than 5 minutes. That means 5 minutes is 0.083 hours. So probability of the time between two calls is less than 0.083 hour. It will be 1 minus 0.1901. Okay, because here you are calculating the probability of the 0.083. So the probability of less than 3, 1 minus, okay, so it will come out to be 0.8099. So the 80.99% is the probability that time between two calls will be less than 5 minutes. Okay, so mm, so in the next class we will discuss on the Weibull distribution, and uh, and also the central limit theorem, the normal distribution, that we will uh, discuss. Uh, but I would like to request you that you please go through the method of Weibull distribution. It is already given in the slide, so you go through it, the Weibull distribution. I will directly start from the central limit theorem. This is you take it as a homework, that Weibull distribution, the Weibull distribution, and I will directly start from the central limit theorem. And I will also discuss these three things are very important: the binomial distribution, Poisson distribution, and exponential distribution. So I will also give you a reminder regarding how to compare these things, or how to very easily understand that when uh, in which particular type of problem, which particular distribution you will select. I will give you an idea about you that how to understand it in a very quick way. Okay. So now I'm going to stop the recording.